When we talk about long run curve, as we said, in a two factors of production, when we consider two factors of production, both the factors are variable. So here we are talking about long run production function, where number one, both the factors of productions are variable, where both the factors of production in a two factor production, both the factors of productions are variable. Yes, and we understand this scenario based on a isoquant, where iso means same, quant means quantity. Yes, isoquant. Iso means same and quant means quantity. But what is this same quantity? We achieve a same quantity of output given different combinations of capital and labor. Of capital and labor. So, I go back to my indifference curve where the satisfaction was same with different combinations of two commodities X and Y, apples and oranges, rasgulla and gulab jamun and so on and so forth. Yeah, paracetamol and two different paracetamols, doctors and nurses, paracetamol and antacid, whatever, any two commodities, and my satisfaction remains same. Here, and different combinations of those commodities where my satisfaction is same on the same curve, which is indifference curve. Here it is altogether same. Isoquant in the same curve, I get different combinations of capital and labor, which gives my IQ stands for isoquant, as IC for indifference curve, and I get different combinations of capital and labor, which eventually, let us take that it is 100 units of, or let's say 100 patients. 100 patients, and over here we can take as doctors and nurses or something like that. Doctors and some other capitals, maybe capital, it can be bed and other equipment. Yeah, and then we can have different combinations of doctors and capitals, or healthcare providers, it can be doctor, nurse, anything, and capital. Yes, in a primary health center there should be at least one doctor, 3 nurses and 1 male nurse. Yes, total 5. We hardly have, in any PH we hardly have filled up that quota. Anyways, so this is the isoquant which gives, and now you can see as it's a long run production function, we can see that both the capital are varying and then the labor can also vary. And while I am varying the capital and labor, we are identifying all different combinations which give me a desired level of outcome. So, if I want to increase, again more is better, I want to increase my production, I can either increase capital, I can increase my capital keeping the labor same, or I can increase my number of labor, I can increase the number of labor keeping the capital same, or if I want to go to this point, I can increase my number of capital keeping the labor same. Yes, so and it varies, and then I can change both the capital and labor to remain on a higher indifference, higher isoquant. That's upon you completely. So when in isoquant we have like the diminishing marginal return. So what happens if we plot this diminishing marginal return on isoquant? What we see, we can observe something like this. Again, as in difference curve, two isoquants cannot intersect each other. They will only shift parallelly. So if this Q, or I can write it as IQ1 is 55, IQ2 is 75 and IQ3 as 90. Okay. Now what I observe is my labor is 1, labor is 2 and labor is 3. Labor is 3. Now, with this 3 labor, when I increase my number of labor from 0, 1, 2, 3, I observe that my the output is increasing by first 20 units and then 15 units. That means the marginal return with every single unit of labor is decreasing, right? So, diminishing marginal return is being followed when it increases from 0 to 1, it is by 20 or say I will keep it like say 1 to 2, it is by 20 units, from 2 to 3 it is 15 units, or from 0 to 1 if you want to keep, then it is by 55 units. Yes, that is a diminishing marginal return, and the same can be observed in terms of capital. If my labor remains fixed at 3 and my capital increases from 1, 2 to 3, and I can see from 0 to 1 for capital 0 to 1 it increases by 55 units, from 1 to 2 it increases by 20 units, 75 minus 55, and from 2 to 3 it increases by 15 units. So, diminishing marginal return is being followed here. Now, when we talk about the slope, if you can remember the indifference curve, the slope is given by the substitutability, marginal rate of substitution, right? The substitutability between two commodities. Yes. Now, here in a similar way, when we talk about the slope of isoquant, we talk about the trade-off between two inputs. Now, that can be stated as marginal rate of technical substitution. Marginal rate of technical substitution. What is different here? The difference is the word technical. The difference is the word technical because it's a production process. Marginal rate. So, whenever it's marginal rate of substitution, we are talking about the consumer behavior, substitution between two commodities. Whenever it is marginal rate of technical substitution, we are talking about technology, we are talking about some production process, then it's like marginal rate of substitution between, whenever it's a technical substitution between two factor of production, like marginal rate of technical substitution, which we can state like MRTS is given, the minus you can give, you can not give, it's upon you, is the change in capital with respect to 1 unit change in labor. It can be the other way around as well, delta L by delta K. So, change in one factors of production with respect to change in the other factors of production at fixed level of Q or fixed level of output, right? Because on an isoquant output is same And when I am at the isoquant, I am trying to see the rate of trade-off substitutability between capital and labor. Yes, and that is given by this delta K and delta L on a particular isoquant where this output is fixed. Yes, therefore, when we are talking about the slope or margin of isoquant or marginal rate of technical substitution, it gives us an idea that for one additional unit of capital, how many labor I will sacrifice, or vice versa. For one additional unit of labor, how many capital I need to sacrifice to remain or to produce a particular amount of output. Yes. So this is the implication, or this is the interpretation of the slope, that with per unit capital or per unit increase in labor, how much capital I am sacrificing. Therefore, in marginal rate of technical substitution gives you an idea about that for say 1 and we can see for 1 unit of labor with while increasing labor, when it is increasing by 1 unit, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, or 0 to 1, how many capital I am sacrificing. Say this is 70, this comes down to 55, this comes down. So here I have sacrificed 15 units, this may be my 45. This can be, so here 15 units, 10 units, this can be 40, this can be 36 or 37 and so on. So the amount of capital I am sacrificing, it's coming down. That's primarily because that technical, and this is called the diminishing rate, you know. So what is happening when I am sacrificing, when I am at the lower level of labor input, I will require more and more of capital. When my labor input increases, I don't want to, my capital input is coming down, and at a certain level I don't really want to sacrifice that many capital, because capital also is also useful and very, very useful. So I will have to keep a basic minimum level of capital, and with the further increase of labor, this labor input is turning inefficient, which inefficiency has to be made up by the capital, the minimum level of capital, because over here if I am causing inefficiency with more and more labor, I cannot afford to lose more and more amount of capital. So that I am being kind of skeptical in terms of sacrificing the amount of capital, so when I am increasing my labor. So this is the diminishing or decreasing marginal rate of technical substitution. Thank you.